Hi, this is Mrs. Young, and this is our lesson on surface area of pyramids and cones. Again, remember that you can pause the video, rewind the video, rewatch the video at any time in case there's something that you miss. Right now for your bell ringer, I'm going to ask that you copy down these definitions or vocab words into your graphing spiral. So go ahead and pause the video now and copy down these terms. So we have vertex of a pyramid. That's at the point that's opposite the base, up at the top. That's going to be the vertex of your pyramid, up at the top. A regular pyramid, like a regular polygon, it's a pyramid that has a base that is a regular polygon. So a regular pyramid has a base that's a regular polygon. Because the base is a regular polygon, that means that all of those triangles are congruent isosceles triangles. And that's going to make finding the surface area a little bit easier for us. Slant height of a pyramid, that's the distance from the vertex to the midpoint of an edge of the base. So it's on the outside of one of your triangles, right? And it goes down to the middle of that base. So it's laying on the outside of the triangle, and it gives you the height of that face, that triangular face. They use a lowercase cursive L for the symbol for slant height. So you're going to see that sometimes. The altitude of a pyramid, it's not drawn in the picture here, but you know that the altitude would go from that vertex down to the middle of the base, and it would be perpendicular to that base. If you want to draw in that altitude, you can. Over on the right side here, we have a picture of an oblique pyramid. When your pyramid's oblique, all of those triangles have different areas. So good news, we're not going to be finding the surface area of any oblique pyramids. We're going to focus on the right pyramids when they're perpendicular to the base, going straight up and down, right? So those are the shapes that we're going to focus on in this unit and in today. Then we have a couple of formulas I'd like you to write down. Hang on. So for our formulas, you have to realize that if you are looking at the surfaces of a pyramid, the lateral is going to be those triangles around the middle. And if we lay them out flat, we can see that those triangles are going to be half of the rectangle, because we know a triangle is 1/2 base times height. So that's going to be used in our formulas. So again, the lateral area is 1/2 the perimeter of the base times the slant height. And then the total surface area is that lateral area plus the base, whatever that base is. So again, I'd like you to pause the video now and go ahead and copy down these formulas for the surface area and lateral area of a regular pyramid. Okay, so we want to find the lateral area and surface area of a regular square pyramid with a base edge length of 14. So again, my base is a square, it's a square pyramid. And then the slant height is 25. So in that slant height, you're going to be using in your formula for the lateral area. And once you find the lateral area, add it to the base to get your total surface area. Probably don't need to round on this one. Again, pause the video. This is a pretty simple one. See if you can find the lateral area and total surface area of a regular square pyramid. Pause. So I came up with a lateral area of 700 centimeters squared. Again, the perimeter of the base was 56. 4 times 14 is 56. And then my slant height was 25. So 1/2 perimeter times slant height, 700 for my lateral. My total surface area is the 700 plus the area of the base. Well, the base is a square, and I know that 14 squared is 196. So when I add those together, I get 896 centimeters squared for my total surface area. Again, that's a pretty straightforward, basic pyramid, finding the lateral area and total surface area. Next, we're going to do another one, but this one's a little bit more challenging. This time we have the lateral area and surface area of a regular pyramid shown below. What's more challenging is that this is not a square pyramid, it's a hexagonal pyramid. So this one's going to take a little bit more thought or work. I'm going to go ahead and help you do this one together. If we're looking for our lateral area, again, lateral area is 1/2 times the perimeter of the base times the slant height. So in this picture, the perimeter of our base, 10 times 6 is 60, right? 10 times 6 is 60. And then my slant height, which they marked in the picture there, I can see it's 16. Again, pull out your calculator. 1/2 times 60 times 16, I got 480 inches squared. So that's my lateral area for this regular pyramid. Next, this is the tricky part. To find the total surface area, I have to add in the area of the base. So the area of the base is going to be the thing that's challenging, and we have to think back to our previous units. My base obviously is a hexagon. Maybe over here to the left, I'm going to draw a regular hexagon. And again, it's a regular pyramid. That means that my base is a regular hexagon. If this side is 10, remember how we would draw in this triangle, right? That if that whole side is 10, then half of that is 5. Remember that if this is a hexagon, this angle right here is going to be 30. So I have a 30, 60, 90 triangle. And if the short leg is 5, then I know that the long leg is 5√3. So the area of a regular polygon, think back, it's 1/2 times the apothem times the perimeter. So this is going to be 1/2 times my apothem, which is 5√3, times the perimeter. 10 times 6 is 60, right? All the way around that hexagon is 60. So again, half of 60 is 30. 30 times 5 is 150. So I get 150√3 for the area of that hexagonal base. So for my total surface area, I'm going to take the area, the lateral area, which was 480, and add to it the area of the base, which is 150√3. Again, don't forget your units. This is going to be inches squared. So again, I've got my lateral area was the easy part. It's the total surface area that I had to think more about. So that was a little bit trickier. Okay, next we're going to move on to, besides pyramids, we're going to look at cones. I do have more vocab or definitions here for cones. You can copy all these vocab words down, or you can even go back to your pyramid page where we wrote down our vocab for pyramid and maybe just include them on that page too. So you've got the vertex of a cone. Again, that's the point opposite the base, right? That's the point up at the top. You've got the slant height. Again, that's on the outside. It's slanting or tilting on the outside. And it's the distance from the vertex of a right cone to a point on the edge of the base. And then our altitude of a cone, which here they did draw it in this time, our altitude is perpendicular to the base. A term that I don't use very often is axis. The axis, again, goes from the vertex to the center of the base. So it might be your altitude if you have a right cone, but if you have an oblique cone, that's going to be tilted or slanted. Again, we're not really going to worry about the oblique cones for surface area. We're just going to worry about the right cones. But these are terms that you need to get copied down. So again, you might want to pause the video and copy some of these down, or go back and put them on your vocab page that you had the pyramid vocab words on. Up to you. So then we also have the difference between a right cone and an oblique cone. You can write these down if you want. You don't have to. In a right cone, the axis is perpendicular to the base. Remember I said those are the ones that we're going to deal with and work on. An oblique cone is when the cone's kind of tilted or slanted, where the axis is not perpendicular to the base. Okay, so again, we're going to focus on the right cones, which is just going to make our life a little bit easier. We do have some formulas to write down. The lateral area of a cone, again, that's this surface right here. That's your lateral that goes around the outside. It's pi times the radius times the slant height. And then your total surface area is the lateral area, pi RL, plus the area of the base, which you know the base is a circle, so that's pi r squared. So again, you want to pause it here and just make sure that you get these formulas written down. So you can pause it, write down your formulas. So here's a pretty easy cone. We want you to find the lateral area and the surface area of this cone in terms of pi. What's a little bit different here is that they gave you the height or altitude, but not the slant height. Again, think of Pythagorean theorem here to help you out. Again, these are the legs of your right triangle. This is your hypotenuse. Use Pythagorean theorem to figure out your slant height. Once you have that, you can go ahead and find the lateral area and the total surface area using your formulas. So again, pause the video right here and go ahead and try to find your answers to this problem. So for my answer, I got a lateral area of 136 pi. And then for the total surface area, I have 200 pi. Again, hopefully you got a slant height of 17. So as far as cones go, this one's pretty easy, pretty straightforward, pretty basic. Next, we're going to shift over to a composite figure. Again, a composite figure is when you put two or more 3D shapes together. Just like I mentioned in our last video, we assume that this is hollow in the middle. So there's not going to be a base on the cone on the left or a base on the cone on the right. We just have to deal with the two lateral areas and then add them together. So again, this is hollow in the middle. There's an opening or gap in the middle in between those two cones. So to find the surface area, you want to find the lateral of the cone on the left and then the lateral of the cone on the right. Again, the cone on the left, they gave me the slant height. The cone on the right, they did not. But again, think of Pythagorean theorem. You can figure out that slant height using Pythagorean theorem. So again, pause the video right now. Find the lateral of the cone on the left, the lateral of the cone on the right, add them together to get your total surface area. So go ahead and pause it. So I came up with a total surface area of 132 pi. So again, the cone on the left was 72 pi and the cone on the right was 60 pi. Add them together, I got 132 pi. My last problem for today is just another pyramid, but it's a little tricky. It's a regular triangular pyramid. So again, finding the lateral area and the total surface area, I thought I would do this one with you. So to find our lateral area, that's going to be the three triangles going around the outside, right? The one back there on the left, the one over there in the back right, and then this triangle up in the front. So you got three triangles total to get your total lateral area. Remember the formula for our lateral area? It's 1/2 times the perimeter times the slant height. So we're going to say 1/2 times my perimeter. So again, if it is a regular triangle, that means that it has all the side lengths the same. That base is a regular triangle. So if this side is 8, this side is 8, this side is 8. So 8 times 3, that's going to give me the perimeter of the base to be 24. And then the slant height they gave me, that was 5. So 1/2 times 24 times 5, that gives me 60 inches squared. 60 inches squared. Next, I have to find the area of the base. And this is the part that I thought was maybe a little bit challenging, just like our hexagonal pyramid, right? So if I'm thinking the area of the base, that base is a regular triangle. Again, a regular triangle is the same length on each side, which makes it an equilateral triangle. If I'm trying to find the height of this, I know in an equilateral triangle, every angle is 60 degrees. So that I know I'm creating a little 30, 60, 90 triangle here. If the whole side is 8, half of that is 4. So that means that the height is going to be the long leg, so it's 4√3. So if I'm trying to find the area of that triangular base, it's 1/2 times the base of the triangle is 8 times the height of the triangle is 4√3. So again, half of 8 is 4, 4 times 4 is 16, so I get 16√3 for the area of that triangular base. So that means that my total surface area is going to be 60 plus 16√3. And again, this is inches squared. So there's the total surface area of our triangular pyramid. Again, real important that it was a regular triangle, which made it an equilateral triangle, so I could find the area of that base. That was our last problem for today. So our homework for tonight, again, I'm slightly altering this from the stamp sheet, giving you a few less problems. If you want to do the other problems, that's fine too. But you're going to do pages 31 and 32, 13 through 22, 28 through 31, and then 33 through 35. Again, just like before, make sure that you take a picture of your homework and turn it in on Google Classroom. So this is your assignment for Wednesday. It has to be turned in by Thursday. Any questions? Let me know. Thanks. Bye, guys.